Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about how you can add another set of fins to a ShipMotion project in the ProteusDS ShipMo3D toolset. So sometimes it's the case you're working on a really big vessel, or there may be other reasons you just want to work with more than one pair of fin stabilizers and see what happens, and see if you can improve in performance or make some other adjustments. We're going to use the 95 meter Generic Yacht. So here's the project. You can see the result from PlotShip here. Now the generic yachts are all configured to actually have the number of stabilizers set for 2 just by default. As you go through the different ship dimensions and loading conditions, you'll see them there. Now if you go down to the ship appendages, you'll see there is something actually here, but the span and the chord are essentially 0, so they don't really have any influence on the results. So when we assemble the ship model and we take a look at it, we don't really see any red appendages here. We'll just do a really quick check here. We'll add keep regular and look at the RAOs. And we'll do knots, 12 knots. We'll just look at the beam case only, just to keep it real simple, and go from there. Okay, so when we plot the motion RAO, so this is essentially of the bare hull. We'll look at the forward speed because that's where the this is a little sharp. Let's go back and just add a bit more resolution to the frequencies. Maybe we'll do this range increment of just a higher resolution for the frequencies. And there we got a little bit better of a defined peak there. So, you know, we're sort of 8.6 is the peak motion roll RAO at forward speed here. But there is some fin stabilizer response here, but I mean they're so tiny they don't really have an effect on the ship. So I would call this the bare hull roll RAO at forward speed. Sorry. There. Now we're looking at the forward speed, so it's actually 12 roll RAO there. Okay, so we'll add our first pair. We'll go back to build ship. I would recommend you change the file name prefix. So we'll call this 2fin. It's really easy to get confused. Now this is the first thing I want to highlight when you've got a pair that is doing something. I'm going to set some pretty sizable fins on this one. They're already at the place I want them to be. So we'll plot the ship, and you can see, you know, they're pretty sizable fins near the front. Now let's check this out in keep regular. Now you need to load the ShipMotion database file name. We want our 2fin result here. It will run the same thing. And when we look at the roll RAO at 12 knots, you see it's gone from 12 to 5.6 at peak. So hey, it's having an impact now. Especially the fin area is going to make an influence on reducing that peak roll RAO. Of course, there's more you can do to characterize the performance, but this is we're just doing a quick example here on adding more. So now you might come to the point where you say, hey, I want to see, this is such a big ship. Maybe we want to add some more fins. Maybe for whatever reason it's not practical to add a bigger fin, so you can add more fins as an alternative. Now, normally you have to be careful with the ship dimension and loading conditions in the ShipMo3D toolset, because if you make changes to them, it may require recalculation of the radiation and diffraction values. Now, an example of that is the height of the CG above baseline or draft. You can't get away from recalculating those, and you should be recalculating them because it's, the hydrodynamics are calculated about the wet hull. But the number of stabilizers is different. So when you're in build ship, if you change this from number of fin stabilizers from 2 to 4, then what you need to do is go down here and we'll right-click on stabilizer fin, add a stabilizer fin, and then we'll right-click on the new fins that were added. So you can change the name if you want. We'll leave it as pair. And I know roughly where I want to put these at station 15, about 2 from midline and from the baseline. We'll use the same size fins just for simplicity. I think I had them at 35 degrees. And we were using a roll velocity gain of something like -3. And let's take a look at what that looks like. Go plot ship, and there you go. So for the purposes of this example, I'm not trying to make a perfectly optimal placement, but I mean, I think you get the idea. We've got a second pair of fins over here. And you know, this is about just kind of characterizing the performance. You might want to adjust that. I'm not saying that I necessarily recommend having them as far back as they are. There's lots that goes into placement. I'm just kind of going through the process of showing how you do it. So now we can go to CKeep regular. See, this is where we get confused. I'm going to call this 4-fin. Rerun that in build ship. Now let's go to CKeep regular. Now we need to change our ship motion for database file name. Okay, so these two are the same. Unfortunately, you know what I'll do is I'll just delete this. I accidentally overwrote it previously with my 4-fin. But this is where you would get confused. If you had all these different ship motion model names, it's good to have them differentiated so you know which one you're looking at. Let's look at the 4-fin one. Oh yeah, and here you need to change the number of stabilizers as well. I know it's a little bit maybe redundant, but it's just a safety check to make sure you're sure what you're doing. So if we leave this at 2, and then we try to run to calculate the RAO, it'll say, hey, look, you said you wanted to do 4 fins or 2-fin stabilizers, but the ship motion model file you submitted has 4. So it's just making sure you are paying attention to some key parameters to what you're doing. So run this again. And now when we look at the motion RAO at 12 knots and the beam conditions, so the bare hull was like 12 peak RAO with 1 set of fin stabilizers. It was about sort of 5.6, and now you can see we've added a second pair of fins working in harmony with the first. We get even more roll reduction with a peak RAO of 3. So again, just kind of showing you the process of adding those. The nice thing about this is that it does not require a recalculation of the radiation diffraction values, even though there's a different number there. And that makes sense because all of this is driven by the appendage modeling, which is independent of the wave radiation and diffraction values. I hope that makes sense. Of course, we're here to answer questions, so send us an email at the support channel if you have any problems. Thanks for watching.